Okay, now that we're a little more comfortable in object references again, we've done a little refresher, I'd like to finish the linked list example that we started in class today. So I gave you the node class, and that was all well and good. The one difference with the code is that we still had an arrow, and we still had the value that the container was holding for a node. But we're very explicit about the fact that an arrow is actually a reference to an object, okay? It's a pointer. We have to say it's a pointer. So for example, this node here has a 5 in it, but it points to this node here that has a 7, okay? So these are references to other nodes. They are not actually full object values of the nodes, okay? So that's important. But personally, I think once you understand object references, I think this makes the code a lot clearer than it was in Java, because now we don't have to think about, well, what happens when I say one object's equal to another object? Am I copying it or not? Well, no. So here I know it's not. This is just a reference. So it's going to be a shallow copy. It's going to be just a pointer to the next node. And that's exactly what we want. We want these arrows that point. Okay, so good. All right, but everything else here was pretty standard. We just said in the constructor, I'm going to store your int. These will just be linked lists of ints for now. We'll see in a moment, excuse me, how to do more general objects. But for now, these are just ints. That's fine. And I have a couple getters and setters. Okay. And I had manually set them a couple up here. So these were object values in the main. I manually set them up so that this node was linked to the next node. But I shouldn't have to do that. This linked list is really what's called an abstract data type. For somebody who uses it, they shouldn't have to worry about the fact that you used a node. That's really your business. And when I use a linked list, I should just say, hey, I want to add something, or I want to delete something, or I want to print it out. I shouldn't have to worry that you're keeping track of things with a node. So I really shouldn't have to do this outside of the linked list class. So let me just take care of that inside of the linked list class instead. So let's look at the code that we had in Java. So the only variable that we had that was a member variable of linked list was a reference to the head. And that's this. So it's just an arrow to the beginning of the list. Okay, so what I'll do, I'll make that private. And again, that's a node pointer, not a node value, because it's going to point me to the beginning of the list. Okay, I make a constructor, takes no parameters. We'll just say that the head starts off being the null pointer. Okay, so that's not too bad so far. Let's fill in the method where we add something. Now my comment was a little misleading here, and that confused some people in class, and I apologize for that. This is actually not adding something to the beginning of the list. This method's really adding something to the end of the list, which is not the best thing to do with a linked list because you have to walk through the whole thing to get there, but it's a good example of how to chase pointers, so I will go through it here. So I just straight copied the code. I'm going to have to change it, but I won't have to change it too much because Java and C++ syntax are very similar, so that's kind of nice. Now I'm just doing ints, not generic types here, so I will just say pass along int value. I'm already in the public block, so I'm going to just say public. And this is good. I'm dynamically allocating a new node, but that means it's returning an object reference. Okay. All right. So that's the change I have to make there. So I say, okay, if the head is null pointer, so if this list is empty, then the head should be the new node that I just made. Otherwise, well, what I have to do is walk along and chase arrows. So here I am, this list is not empty, the head points to something. So I'm going to make something called node, which moves along here. So it starts off here at the head. So that's what happens when I say node equals head. Well, they point to the same thing, they're the same reference. But then I need to go to the next one, and the next one until I find that the next one would be null, and here it is. At that point, whatever I'm trying to add, so this new node, let's say I was adding an 8. At that point, I would then change the next arrow to point to the new node. Okay. So we basically have the structure. We're just going to have to change a few things. So this is an object reference, and also my next arrow is a private variable here. So I have to use the getter. So I'll use the arrow notation since I'm with the reference. Get next. Well, that's not the null pointer. Then I'll say node is equal to node arrow get next. Okay, cool. And then same thing down here. This is an object reference, so I just have to say node arrow update reference new node. Okay, so that's the translation of adding something to the end of this linked list. Again, not the best operation for a linked list. This is kind of takes as long as you possibly could. It takes as long as the length of the list to get to the end before you add something. It's much better to add something to the front because all you do is change the head, which I'll have you do in a moment. But it's good for illustration of what we're doing. Okay, just so I can see what I've done, let me also add the toString method. And even though there isn't such a simple toString in C++, I can still make a method that prints things out. So I'll just call this print list. And what I'll do is very similar to what's happening here. I just, again, I'm very explicit about the fact that I am chasing references here. Okay. So, and this is just going to be a void method actually, because I'll just, instead of constructing a string, which you could do, you would have to include the string class like we showed before, but here I'm just going to use printf. So what I'll do is I'll just printf, and I guess I'll put a comma in between each one. So I'll say node get value, and then node is equal to node next, or get next. Okay. And I might as well print a line break at the end. Okay, so let me see if I can make the list that I had here. So I'm going to add a 5, I'm going to add a 7, 4, and 8. So I'll say linked list L. And I'm going to do something which I shouldn't do, and I'll show you the problem in a moment, but which is a little weird. The explanation for why is a little strange, but anyway, but I should, so that this is making just like an object that's local to the main. So remember, when main is done, it will be deleted. We don't have to worry about deleting it ourselves. So then we'll say l.add_last. And what was again? I said we're adding 5, 7, 4, 8. Okay, so we'll do 5, 7, 4, 8. And I will print out the result so we can see we should have 5, 7, 4, 8. Okay, so let's go ahead and compile and run this. Oops. Okay, it is telling me some weird stuff that I haven't seen before. Error, request from member add last and L, which is of non-class type linked list function. Okay, so C++ is getting very confused here. There's kind of a downside to using this syntax in C++. It thinks I'm declaring a function here. It's very stupid. It's thinking I'm declaring a function called linked list, and it's like, well, function's not a class. What are you trying to do? This is just a little pitfall that you can fall into if your constructor has no arguments. So the way to deal with it is just, turns out, if your constructor has no arguments, then you can just declare an object like this, and you'll be fine. So some students were running into this in class as well, and I forgot what the reason was, but that's the reason. Okay. So now we're fine. So it just constructs it, whatever. We don't need to have any parameters. And now if I run the linked list, I get 5, 7, 4, 8. Beautiful. Okay. So that's good. Now, what I'd like to do is just finish this up to remove things. And hopefully some warning bells are going off in the back of your mind when we had a new, but we never had a delete. So we do have a memory leak in this program, actually. And so let's try to deal with this. What we'll do is we'll add a method to remove a node, and we will make sure that at that point we delete the node from memory. So I'm just going to add a method. I'll keep it simple. I'll just remove from the beginning. So void remove first. Well, actually, let me return the int that's there as well. Int remove first. Okay. And I'll just do something stupid. You know, if this is not great practice, but I'll use -1 as my magic number for, hey, there was nothing there. Okay. So if my list is empty, so I should be careful. So what I'll say is if the head is not the null pointer, then I can actually go in and remove something. So what I'll say is, okay, ret is equal to head get value. And I will say head equals head get next. Okay. So let me just make sure that this, if I call this 4 times after I've done this, that it actually prints out these numbers also in order, because I'm removing them from the beginning. So 5, 7, 4, 8. So after I've added them to the end, I'm going to remove them to the beginning. So I'll say 4 int I is equal to 0, I is less than 4, x plus, printf, or let me put a space. So I'll say L dot move first. So just make sure this works before I worry about that memory leak, which I'll address in a moment. Okay, so let's compile that. Okay, cool. So remove the 5, then remove the 7, then remove the 4, then remove the 8. And actually, if I keep going, it should be smart enough to know that I shouldn't remove things anymore. I should just print -1, -1, -1. Okay. So this is working. But what I have to do is if I find that I can remove a node, I should actually delete it too. So what I should say is, okay, before, that's fine, I'm gonna get the head's value, but what I'll say is, I'll store a reference to what the head's going to be, but before I change it, I need to actually go and delete what the current head has. So that's very important. So I just want to show you, running the program, you won't see a difference, but, oh, abort core dumped. So what did I do wrong here? Oops, I meant to say head equals new head. Not new head equals head. Okay. See, even I make mistakes. Okay, so we get the same behavior, but we're deleting everything. So what I should do is exploit this method to clean up the whole list. Even if I don't manually delete elements, I should be sure that when this list is deleted, like if this were in some method, so I'll say void test list. So if this were in some method here, I should be assured that when the method is done, it cleans up whatever is in the list, right? Because I told you it's supposed to delete all these variables. If it deletes what's in the object, but it doesn't delete the references that the object has created, then there will be a memory leak. So what I have to do actually is create a destructor. So what I'll do is I'll say, while head is not the null pointer, remove first. Okay. And just to show you that something's actually happening, I'm just going to print out whenever it removes something what the value is. So I'll say printf removing ret. Or no, yeah, right. Okay, so what you'll see is when this method's done, it should say, delete 5, 7, 4, 8. even though I never called them myself. They're going to get called in the destructor. Okay. So let me do this. Excellent. Okay, so now we've cleaned. Now we're good. We have it cleaning everything up. So just to make sure that you're comfortable with all this pointer stuff, I'm going to have you implement the add first method as well, which is a lot shorter than this. You won't even need a loop. You'll just have to update some of the object references. You'll have to make a new node, and then you'll have to make that node the head, but then change its next to be what the original head was. Okay? So go ahead and do that. And then the last thing I'll talk about is how to make this generic. So we were using ints here, but what if we wanted to store arbitrary objects? Okay.